I'm Dr. Frank Granito, Chief Scientist with the Institute for Digital Transformation. I want to welcome you to Digital Dialogue, where different industry experts discuss digital transformation topics and issues that are of concern to all businesses. Whether you are already a digital enterprise, or on your journey, or still trying to figure out what that all means, we know you'll find something here for you. Remember, as a LinkedIn Live session, this is your opportunity to interact with these experts. Post your comments and questions in chat for a full interactive experience. Welcome to Digital Dialogue.
Thanks, Frank. Thanks for welcoming us in. I'm Ray Sheen, one of the Institute fellows, and I want to talk with you today about innovation. I'm going to bring along a few of my friends to help us with that discussion. Innovation is something that's been around, obviously, for years. We've all been involved in it. At least many of us have been involved with it. I've been involved with it for nearly 40 years. But there's been some changes in the way that we see innovation happening, and those changes are being accelerated by digital transformation. Let me bring in a couple of my friends and we can have this discussion. So let's bring Rick in.
Hello.
Rick, hi Rick, if you'd take a moment to introduce yourself, and then we'll have Venkat join us and we'll get into our discussion.
Sure. Rick Morse, career of 35 years in industrial automation space. Started with what is now Fanuc Robotics and creating their industrial controller, and have moved around the industry doing PLCs, CNCs, DNCs, anything with a three-letter acronym really that controls things, to help companies transform their manufacturing and control space through the use of innovative technology. And I love this space because I get to learn a new problem and apply new techniques every year.
Thanks, Rick. Venkat, why don't you join us too now and give a little introduction and some of your background.
Sure. I'm Venkat Krovi. I'm the Michelin Smart State Chair Professor for Vehicle Automation at Clemson University's International Center for Automotive Research. So I've worked in the space of robotics and automation now for about 25 years. And over this time, had the opportunity to work in different areas: surgical robotics, vehicle automation, multi-agent systems. And I think I'm looking forward to the conversation on how the field is transformed over the time Rick and I have been in this.
Yeah, that's interesting. All of us are, we're all a little bit long in the tooth. We've all been around doing innovation work for a number of years. But we've seen some changes, and we've seen how the process of innovation has been changing recently. Rick, why don't you give us a couple of your insights into what is different about doing innovation today as compared to when we did it 10, 15, 20 years ago?
I think the tools that we've got and the processes that we have are a little more refined than the stumbling around in the dark with stone knives and stick axes that we had 25, 35 years ago. We were very comfortable moving from Gen 6 to Gen 7, from a PLC 5 to a PLC 6 to a 7 to an 8, because it just felt like a general progression. But as people were stepping back and seeing the huge gains that you could get by applying new technologies in completely different ways, and collapsing some of the previous tools that we had to attack the base problems, all of a sudden people started going after the why. Why are we applying these tools? And then maybe putting the tools together differently, or even inventing new tools to innovate new solutions around this space. So I think we've gotten more savvy about going back to the root problems and innovating real solutions to those problems with the current technology as it evolves so quickly.
Venkat, you're probably as up to date on the tools as any of us. Would you agree with that, or are the tools really making a big difference right now? What would you say?
So I would actually take a slightly a different perspective, actually a historical throwback, if you wish, right? The idea, so robotics now is about 60 years old. And we had a 60-year celebration recently. And if you were to ask what has really changed in the 60 plus years of robotic, and was there any particular point in time when this happened, you'd be hard pressed to pick one point in time. But what I like to tell my students is that we're in this era of what I call digital redesign. Take things that are fundamentally mechanical, analog, if you wish, and through additions of interfaces, convert them into digital entities. Some of these robots, etc., were are already intended to be operating with digital background. There might be other things that were not, and that you're now essentially retrofitting them using the applique model to make them digital. And of course, in this modern era, you have things that are born digital. But the net effect of this digital redesign paradigm has been to provide essentially what I call digital insight into a fundamentally opaque analog world. And this ability to do that, to get data and to modulate power, sensory information and power in this digital space now becomes that much easier. You can, there'll be other anecdotes I'll talk about in a little bit, where your ability to fundamentally perform the same function with multiple different approaches gets amplified, souped up, if you wish, once you're transformed it into the digital world. And so that I see as the major transformation that has occurred. And if you said, is there any one particular point in time when this has occurred? I'd say we're seeing a flattening of the analog world. Happy to give you more details on this as we go along.
So let's explore that a little bit. Back early in my career, I was involved in creating flight simulators for the Air Force, and that was creating a digital world that the analog, the flying the airplane. You now are doing that in the digital cockpit and a digital world, and through that we were able to significantly enhance the training environment because of that. Now, what I'm seeing and with the current simulators, they're able to go that much faster, that much have that much more capability to them. And it's really, we've seen this growth of the idea of the digital twin, that in the development world, we first design a product digitally before we ever even build it in the physical world. And I know you've done some of that, Venkat. Do you have an illustration you'd like to give us of how that's changing the design approach or the innovation approach?
Yeah, sure. Thank you for that. So since I'm now in an automotive engineering department, right, I end up using a drive-by-wire as a classic example. In a yesteryear, you might have had a steering subsystem in a car that now connects a steering wheel now to drive wheels. When you transform that into a steer-by-wire system, at face value, you're actually degrading performance, because you end up requiring a high-fidelity encoder and motor at the drive wheel. You'd require a high-fidelity motor at the rack, and a computer now just to transform the signals from one to another, and to simply recreate the same performance that the original analog system could do. But what you lose in initial performance, you gain in flexibility. So you could now have two steering wheels. You could take your steering wheel, put it anywhere you want in the car. You could have a steering wheel and a joystick. Your second steering wheel could be in Tokyo. Your second steering wheel can be a computer. And it's that ability to mix and match that you can do to signals and power but now in the digital space is what ends up creating opportunity for innovation. So you could say, can I now layer power steering over this? Can I now layer a map-based localization and autonomy onto such a system? These all start to come into the realm of possibility, and to that extent, you can do things better, cheaper, faster, once you only have to manipulate things in a digital space. And so that is where the value creation and the innovation opportunity, in my mind, comes from.
Okay, better, cheaper, faster. Well, that's something I've been hearing for years. Rick, I know in some of the factory automation stuff, that was the mantra of what you're dealing
Absolutely.
with.
Absolutely. And to just pile on to Venkat's story, I'm a mechanical engineer by trade, but the thing that I've really been working with is more electric motors than mechanical gears and replacing them. And there was a project a number of years ago that worked with a very innovative team in Italy. They were trying to make a packaging machine for a product that ran at 10,000 units a minute. And at that speed, you cannot see the individual units go by. I won't mention what the product is, but um, the intent was to make something that went twice as fast as the previous generation that was gear and cog driven in half the footprint, and be able to give extra capability to it. And what the hard geared product never was able to do was, if there was something wrong with one of the individual products as it was flying through space at 10,000 products a minute, if there was an individual error, you couldn't have the option of ejecting that one to get it out of the way because you didn't want that one in the package. So we replaced something that had 75 motors and gears and cams and all these fun things with 80 individual electric motors that were all electronically geared through the use of computers and sensors, and could pick up with strobe lights and vision systems, high-speed vision systems, pick up an individual flaw in one of those products and eject it as it's flying by in the stream of product at 10,000 products a minute, because they're all electronically cammed. And so for an individual product, I could do one motion or a different motion. I wasn't hard geared into a particular action. And it made this company create a product that literally was half the footprint of the previous generation, ran twice as fast, and eliminated all errors in the outgoing stream.
Wow.
Cheaper, faster, better. Because we were going from hard physics to electronics and innovative application of data.
We're gonna, the three of us, I know, given another couple minutes, we're gonna get even deeper into the weeds on technology. I want to step back from the technology for a second, though, and talk about the culture around innovation. You know, agile is a big word that's used often, but let's just think about, how does the culture of innovation, how has that changed? I'm seeing a lot more people working in teams. I'm seeing, and these teams are international teams, people from all over the place. I've been on calls, several calls today already, with people that are in other continents as we're dealing with innovation topics. How are you seeing the innovation culture changing as we're going forward with this? Venkat, I'll let you go first on this one.
So there was a talk recently that where we had somebody from GE Digital speaking about the pace of technology, and it was Industry 4.0 and now Industry 5.0, and all the usual jargon was being sort of repeated. But he made an interesting observation. he said, how many of you have heard of Industry 4.0? And, pretty much all the hands in the room went up. And then he said, how many of you actually have digital transformation teams in your organization? Even if it is somebody, one day a week or one afternoon a week looking at some of the technologies. And in a yesteryear, all of this might have been considered IRAD function,
Right.
internal R&D. But in this day and age, the pace at which some of these technology is hitting people, there comes a clear need for being able to evaluate, even become aware of the technology, and then potentially evaluate and in pilots or other frames. And so it's in that sense that at Clemson and at ICAR, one of the things that we are looking at is finding ways in which we can match students with these technologies so that actually benefits to both parties. Our students now get to play with some of the latest and greatest of technologies, with the caution, of course, that they are students and they're learning and they may or may not get to the answer. But the evaluation of the technologies is something that you can actually support at the industrial partners end. And unless there is a intentional approach to doing this, I suspect that much of the technology and the benefits might just whiz by. So that would be our perspective on what we're seeing.
Okay, I noticed a question came up of who has innovation teams or digital transformation teams. Rick, have you seen that anywhere?
I have. A lot of it, as Venkat mentioned, is the kind of the outgrowth of what used to be internal R&D. They're now more focused and more shaped to be maybe an internal innovation team. And part of them, you'll see them in the manufacturing space to where they're focused on the processes of how something is created. But then you've got a few others that are focused on how the product itself solves a problem. And I think you're seeing a lot of innovative products come through the mill that I think part of it is generational. I mean, we all here have lived through two of the industry 0.0s in our lifetime. And while it was decades before, to get from steam engines to internal combustion to, the first two, 1.0 and 2.0, were long in coming to get to 3.0, but we're seeing 3 to 4 really fast, and that the generations behind us have no real understanding of a world where things stand still. They expect things like this to actually evolve every year, right? They don't expect to be driving the same car that that their dad was 10 years ago or something like that. They expect that fast-paced change. And so I'm seeing more and more generationally when I hire teams and such that they are looking for how do I muck up what was been done before by your generation? How do I change that? Rather than the tried and true. When we came in, it was like, all right, whatever you do, don't screw it up, right? And if it works, don't mess with it. Whereas the new generation comes in really with, okay, it works, but we can make it better, obviously, because there should be a new release next year.
Yeah, it's
Right.
interesting.
So some of it's culture and attitude.
Yeah, it's interesting. There's a KPMG report out there called the rate dilemma. And what it talks about is that it used to be that the auto industry, new product development was on a 7-year cycle. And until Tesla came along, and suddenly it became a 2-year cycle. And in some cases, even leapfrog 1-year cycle. And to the extent that people said it couldn't be done. But once the mold was broken, it has created disruption, but it's also created opportunity in fundamentally new ways.
Yeah, that's part of that culture change that's happening. The pace of change so much faster. I remember as I was running engineering groups in industry, our focus was around stability. Get the process working well, and then just crank it, keep it stable. Now we are constantly updating, constantly changing. Stability means you're falling behind rather than moving forward, because this constant change is one of the attributes that we see in the digital transformation. I know I've seen also some of these digital transformation teams. Most of the time where I'm seeing those in industry right now, they're focused around the interaction with customers, and really trying to get a much closer connection to customers and getting customer data, customer accounts, customer feedback. Have you seen that impacting the product development arena? Venkat, anything you've seen there?
So yes and no. So in a yesteryear, product feedback was through like what I call analog methods, which would be Likert scale based, measurement of product satisfaction, and it would take a while for it to propagate back. Um, you mentioned digital twins a little while earlier. This idea of, as you're looking at a product and it's going through its life cycle, often in the hands of customers, are there things that you can now do in measuring in situ the performance, the operating conditions, and use that to potentially drive the product development portion or the predictive analytics portion, which is continuous maintenance for this. This is again from the perspective of a lot of the automakers. They are looking at this as becoming the new digital gold, if you wish. And the question that I think a lot of them are asking is, yes, we need people who are well versed in the traditional technologies, all that goes into developing an automobile. But increasingly, as the automobile has now become a software defined vehicle in various shapes and forms, whether it's the infotainment perspective or the other dimensions, how are we going to fulfill the requirement for the human resource, the human capital, the human infrastructure from both the initial product development perspective, but the continued maintenance and repair, and ultimately the recycling perspective. So it's become a problem in the auto sector, but just about everything that you touch and feel today, consumer electronics, when VCRs became DVRs, when home security systems became digital, you're seeing this convergence of, I call it the triple convergence of miniaturization, computing, and communication, so that you're embedding intelligence in situ in this traditionally analog product. That I think we're up for some interesting times moving forward.
I would agree with that. Rick, I happen to know that at least one of the projects you're working on now, you're dealing with platforms that are doing exactly what Venkat was just talking about. Any observation or comments? How is that working, and what are the barriers that you're running into as you're trying to do innovation in that space?
So one of the biggest barriers is that you have to start with that digital twin knowledge. Just because you have a computer and you have an abstract form that you can create, you have to make the digital twin smartly. You have to understand the physics behind what you're trying to measure and be able to put all the right sensors and things into it. Been working with large capital equipment for a number of years. They're actually way ahead of the automotive guys in monitoring and measuring the performance of their equipment and being able to feed that back into driving maintenance and doing maintenance more preventative and diagnostic as it starts to decay. But they have to build all that digital twin information into from the beginning to say, well, gosh, do I need the pH of the oil, or do I need just the thickness of the oil? So that they can put the right sensors in. So it's the same conundrum as the old object-oriented design. Everything makes sense if you create all the right objects because you understand the world that you're going to model completely. Well, if you understand enough of the physics of what your twin is going to know or needs to know to manage itself, you can make a good model that can actually drive behavior around the maintenance and the performance of these large capital equipment, and eventually down to cars and consumer equipment. But it does take some a priori knowledge. You don't throw out all of the knowledge of the analog world. You got to bring that along.
Yeah, there was a time when aircraft engine manufacturers would sell their engines at a discount because it was the lifetime maintenance that you're alluding to, the CapEx.
Right.
Yeah, and increasingly, right, I think that there was a comment about what do students need to know in this new world, and I actually make an argument that the burdens we're placing on them, we're asking them to be truly Renaissance engineers. You asking them to know one subject, one topic very deep, but have enough visibility and enough overview of all the different ways in which that one topic could be affected. And I think there's a little work left.
I think that's a great aspect, because I've seen education shift to where, oh, well, everything's just software. And it's like, no, because the innovation is happening around a problem. The original problem is analog. It's here in the real world. And so you have to understand what the physics, what the real constraints of that real problem. The more you understand the real world and being able to apply digital technology to that as a tool, not as the end, but as a tool, the better equipped you are to really make some amazing contributions.
Yeah, let's shift gears just a few minutes, because we only have a few minutes left. Are there any questions that we can answer? Anyone with anything? Anyone who's been listening? I've seen a couple of questions pop up, and we've tried to address them along the way. But does anyone else out there have a question they'd like us to address?
Maybe while that's coming up, I'll say, just tongue-in-cheek, one of the C-suite people in the cloud space, I had a person tell them, you have your head up in the cloud if you cannot actually actualize it in the real world.
Yeah, Patty made the comment that the digital is the enabling tool. It's not the end all, and I think that's really been at the heart of what we've been talking about. We've talked about it digital, but it's really, we're solving problems. That's what's behind innovation: solving problems, dealing with the issues that real people face in the real world, and using digital technologies to help us do a better job of addressing those. And
it's Venkat's triple convergence that's given us the better tools. My first robot that I all the way down to the operating system drove had a computer the size of this apartment that was in the next room just to drive the servo loops. Right. You know.
And yeah, I use similar analogies, right? And I think the ENIAC, I did my graduate work at University of Pennsylvania. The ENIAC filled an entire room, and 50 years later, they did ENIAC on a postage stamp.
Right.
But to that extent, I think what the challenge now becomes is that I think we have we have an embarrassment of riches, in that the numbers of ways in which you could potentially solve the problem have now multiplied, and in your inability to pick the right one, oftentimes sort of may grind product and process development to a halt. And the only opportunity that I suggest to our students is that go do an internship, go work with industry, see how they're solving the problem, because your solution, while it might sound really good here in a classroom, may not actually pass the test of reality.
Well, and you bring up another good point. Don't try to do it in a vacuum. There are so many new technologies coming along. Whatever you do, do it as a team. Find other experts that are around you in adjunct spaces. Get connected with them, because somebody's going to come along and say, well, that's very interesting, but why aren't you using some cloud technology? Or why aren't you using some embedded technology? Or why? And they'll go, oh, I didn't even think about it. I'm not an expert in that. I had no idea where that had gone to in the last 5 years.
But I think Ray actually pointed to an interesting point earlier, which is there is a generational transition that is occurring at this point in time.
Right.
I used to call them in the context of buildings, the building whisperers, the machine whisperers. They understood innately how things function, and that not knowing what is the expected performance of a complex system is going to hamstring, I suspect, how we approach these things in the future.
You used the term system there, Venkat, and I think that's a good place for us to wrap up. Is we're no longer operating in the silos. So whether you're a mechanical engineer, or electrical engineer, you are a chemist, a physicist, we're now dealing with systems, and the systems have physical components, digital components, people interacting with that, and it is now a far more complex system, which gives us tremendous capabilities and opportunities to do all kinds of things we never could do before. But it also means that there's a lot of work there. And that's part of where the innovation is coming from, is looking at different aspects of the system, constantly challenging the system to be able to do new things, to do them better, to do them in a more efficient and effective manner. Let's close off. I'll let everybody give a last comment. Go ahead, Rick.
Yeah, to that point, the breadth of what you have to understand to really bring some of these new innovations to bear cannot be grasped by a single person. I've worked with some amazing people, but you can no longer do it just by being a really amazing mechanical engineer and coming up with that machine that moves things through it at 5,000 units a minute, because that was all just mechanical. Now you need expertise from so many different groups and so many different fields that it's moved from an individual sport to a team sport. And I think that is one thing that companies who face this intentionally and go after it in how do I build teams? How do I run teams in the innovation space, rather than just nurturing the guy that you're going to stick in a closet and shove a pizza under the door every now and then and let him come up with things. No, it can't be done that way. It has to be done as a team sport, and the team dynamics, the organizational behavior dynamics, has to be part of the formula for those who are going to succeed at this.
Great comments. Venkat, your closing comments.
It's hard to follow a closing like what just Rick said, but I think the interdisciplinary dimension and the teamwork dimension, the future is going to be socio-technical systems for the foreseeable future. We still haven't reached a point where we can simply take the human out, and to the extent that we cannot fathom the diversity of humans who would operate. People talk about flight simulators. flight simulators are flight aircraft are operated by people who are very specially trained. If you wanted to start deploying the same type of capability now with your 𝗗𝗶𝗴𝗶 public, it creates enormous new, how shall I call it, opportunities for innovation. And so
Right.
I'll leave it with that.
Okay, well, thank you. And Rick and Venkat, thank you for joining me today on this dialogue. I found it interesting, thought-provoking. I enjoyed it. With that, Frank, I'll turn it back over to you.
Thank you for joining our digital dialogue. Be sure to join our next digital dialogue on the first and third Tuesdays of every month.